Hey friends, my name is Z and you're watching MakesItEasy. And welcome to a new video for IGCSE Maths, and today we have coordinate geometry for rules and examples for coordinate geometry. And we looked into questions only for quadratic expressions and equations last video, and in our next video we move on to questions only for coordinate geometry. But anyways, here's rules and examples for coordinate geometry starting with equations. But before you get into it, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And let's get into some equations. So firstly, we have distance between 2 points on a Cartesian plane, or like just a graph. So we have A and B as 2 points, the absolute value, so like A and B can't be negative because distance can be negative. So let's say we have A as x1, y1, and B as x2, y2. The distance between A and B would be the square root of, the square root of y2 minus y1 squared plus x2 minus x1 squared. So let's just highlight some points here, x1 here, oops, here, and here. And for the B point, x2 and y2 will be here. So basically how we derive this equation is that we take this Pythagoras Theorem, a squared plus b squared equals c squared, to find the distance. So let's say we have a graph right here. Let's say A is here and B is here, B and A. Let's say this is 1, 3, and this point here, B, is 2, 5. So what you would do is that you're trying to find this distance right here to find the distance between A and B. So what you're actually finding is that you're trying to find this and this. You actually can form a triangle, and this will be A, B, and C. So essentially, A, B, the distance between A and B is basically like C in the Pythagoras Theorem. So in this case, A squared plus B squared equals C squared. And to find C, which is the distance of A, B, you would do square root of A squared plus B squared. And A right here is basically just 5 minus 3, or y2 minus y1 squared. And B, which is right here, is basically 2 minus 1 squared. And number 2, the midpoint. The midpoint, which is like a big M here, equals x1 plus x2 over 2, and comma, y1 plus y2 over 2. So if we have, let's say, the same point, A, sorry, let's just wrap this out. Let's just like write it out. A as 1, 3, and B as 2, 5. You would find the midpoint of AB as 1 plus 2 over 2, and 3 plus 5 over 2. And if you simplify this, it will basically just be 1 plus 2 over 2, which is just 3 over 2, and 8 over 2, which is 4. So this would be the this right here would be the midpoint of A and B, because you're like finding the average between x1 and x2 and y1 and x2, so like find the midpoint to find the midpoint of the whole equation, so the whole like coordinates. Then we have more equations. So we have a gradient equation right here, gradient, and in a straight line equation of y equals mx plus c, you know that this m value right here implicitly means the gradient. So there are multiple ways to find gradient, and this is one that I use. The gradient is y2 minus y1 over x2 minus x1, right here. Or you can think of as rise over run. Because in a graph right here, let's say A, B, and again, A and B, the gradient is basically the rise over run. And this rise value is basically y, and this run value which is basically x. So it's basically y2 minus y1 over x2 minus x1. And you can of course do y1 minus y2 and x1 minus x2, but make sure to write the same like x1 and 1 and 1 in the same order. So if you put y2 first, like 2 first, then you have to do 2 first. For example, you could be like, let's set A as 2, 3, and B as 3, 5. The gradient could be y2 minus y1. Let's set this as like 2 and this as 1. The gradient could be 5 minus 3 over 3 minus 2. Or if you want to do it the other way around, y1 minus y2 over x1 minus x2, it could be 3 minus 5 over 2 minus 3. They'll be the same, but you have to make sure that the order is correct. Then we have an equation of a straight line. So there's basically two equations, y equals mx plus c, the most standard one. And there's this where you have y minus y1 equals m, the gradient, and brackets x minus x1. So you need like a coordinate of like y1 and x1. Then we have a negative reciprocal. So the idea of a reciprocal is that you flip the numbers around. Like in a fraction, you flip the denominator and the numerator around. So if we have 2 over 3, the reciprocal of 2 over 3 will be 3 over 2. And the reciprocal of 2 is 1 over 2. Because 2 is basically 2 over 1. And if you reciprocate it, it will be 1 over 2, which brings us right here. So the negative reciprocal is basically you first reciprocal. Number 2, add a negative sign. So negative reciprocal would be useful when we look into perpendicular bisector later on in the next slide. Basically, yeah, flip and add a negative sign. As you can see, m1 and m1. So here's an extra information for gradient. So y2 minus y1 over x2 minus x1 times by x2 minus x1 over y2 minus y1 will be equal to minus 1. Because it basically cancels this out. So this would be useful when you look into perpendicular bisector or like finding like different gradients if they meet at like 90 degrees. Then here we have some equations again, and as I said, perpendicular bisector. So basically perpendicular bisector is where we have this line right here. Let's call this line AB, and the other line of line CD. Perpendicular bisector means that CD meets at the midpoint of AB, at the mid, with a capital M, and they're equal distance, and that's a perpendicular bisector, and they are in 90 degrees. So what you have to do to find the perpendicular bisector of a line is that let's say we have only A and B. We know A and B. Let's say A is like 2, 3, and B is like 3, 5. What you first have to do is that you have to take the gradient of A and B. So this will be 5 minus 3 over 3 minus 2, which is 5 minus 3 is 2, and 3 minus 2 is 1, so it will be 2. Then you will do negative reciprocal. Let's just highlight this. Then you will do negative reciprocal. 2 will be equal to minus 1 over 2. And let's just highlight this. Negative reciprocal. Then after you have a new gradient, you have to find the midpoint between the two coordinates that you know, because basically perpendicular bisector is it meets in the midpoint, as I said. So the midpoint of AB is basically 3 plus 2 over 2 and 3 plus 5 over 2, which is 5 over 2 and 4. And right here, midpoint. So after you have the new midpoint and a new gradient, you just equate them together to find the new equation. So here we have this new gradient is minus 1 over 2 after doing negative reciprocal. The new midpoint is 5 over 2 and 4. The new equation would be y equals minus 1 over 2 x plus c. You substitute the equation to get 4 equals minus 5 over 10, or 1/2 basically. Sorry, 5 over 4, not 5 over 10. Yeah, plus c. And the new c will be 4 plus 5 over 4. Or it's basically 16 over 4 plus 5 over 4, or 21 over 4. Therefore, the new equation on top right here, the line CD would be y equals minus 1 over 2 x plus 21 over 4. and use a new gradient, as I said, to find a new equation. So here we have an example, as I said just now, like A and B. A, B, you find the gradient of A and B and do negative reciprocal. And let's say if the gradient is minus 2, the negative reciprocal would be 1 over 2 because you reciprocal the minus 2 to get minus 1 over 2. And you add a negative sign, and the negative sign cancel each other out to get 1 over 2. Then find the midpoint of A and B to get 4.5 and 4. And use the gradient equation y equals mx plus c to find the new equation right here. And here we have more equations, and it's to find the area of a polygon on like a graph or like a Cartesian plane, and it's called the Shoelace Method. So what you want to do, number one, is that you choose a point, and I'll show an example in the next slide, so don't worry if you don't understand anything. So first you choose a point. Let's say you have like lots of different points. You choose a point, like you plot all the points on the graph and just to observe like where their positions are. You choose a point and go anti-clockwise and write down the points in order, and you have to end with the same point. And use the shoelace method to multiply each side, and use the shoelace method or formula of this to find the area, 1 over 2 and y minus x. Or basically you have to do like 1 over 2 and the right side minus the left side. So what I mean is that let's say we have this area of a polygon, we have different polygon like points, like A, B, C, D, E, F. A is minus 2, 5, B is 4, 4, C is 0 and 1, D is minus 6, 0, E is 5 and minus 2, and F is minus 1, minus 4. So if you plot it on a graph, A would be around minus 2, 5 here, A. B would be 4, 4, 4, 4, B. C would be 0, 1, C. D would be minus 6, 0, so minus 6, 0, D. D. E will be 5 minus 2, which is a bit here, E. And F is minus 1, minus 4, minus 1, minus 4, right here. So F. Oh, sorry, this is E. So we can join like the whole like different points to get this rough shape right here. So it's not possible to use any area formula because this is not like a regular shape, and you don't know if this is like a regular like square if you cut it like this or not. So you can use the shoelace method. So you choose a point to start with, and I choose to start with the point 4, 4, which is basically 4, 4 is B. So I choose to start with this point right here, B and B. And you have to end with the same point as well. And what I did was that I went anti-clockwise, as I said just now. So I go with 0, 1 right here. And then I went minus 2, 5, which is A, minus 2, 5. Then I went minus 6, 0, which is D. Then I went minus 1, minus 4, which is F. And I went and I went 5, minus 2, which is E. And I have to end with the same point of 4, 4. And after you've written all of those points, you zoom in, and let me just zoom in. And this is actually 5 times 4, not 5 times 5, 5 times 4. So what you do is that you have to do like cross multiply, so like 4 times by 1, 0 times by 5, minus 2 plus times by 0, minus 6 times minus 4, minus 1 times minus 2, and 5 times 4, and write it out here in the left hand side. So 4 times 1 is 4, 0, 0, 24, 2, and 20. And once you have all the numbers that you cross multiply for the right hand side, you add them all up. Add 24 plus 4 is 28, 28 plus 2, 30, 30 plus 2 is 50. So the right hand side you have 50 right here. And after you've done the right hand side, you do to the left hand side as well. So like 4 times by 0, 1 times minus 2, 5 times minus 6, 0 times minus 1, and minus 4 times 5, minus 2 times 4, as I say right here. So it will be like 0, minus 2, minus 30, 0, minus 20, minus 8. So you add them all up, like minus 20 plus minus 8, minus 28, minus 28 plus minus 2, minus 30, and minus 30 plus minus 30, minus 60. So if we say this is like y and x, or you can call it any variable because they are not technically x or y. The area formula that you have to do is half the right hand side value minus the left hand side value. In this case, my right hand side value is 50. Right here, let me just highlight it. My right hand side value is 50. And my left hand side value is minus 60. So you have to do half 50 minus 60. So it will basically be half 50 plus 60. 50 plus 60 is 110, and the half of 110 is 55 units. So the answer is 55 units for this whole polygon. So it's this idea of cross multiplying that you have to really understand. Let me just rewrite here, rewrite it, and let's just write 3 points, like 4, 4, 0, 1, minus 6, 0, and 4, 4. What you have to do is that you have to cross multiply like this, cross, to get 4, 0, minus 24, add together to get minus 28, and you cross multiply this, and this, to get minus 6 and 0, so it will be half minus 28 minus 6, and you have to get the absolute value of this, because area can be negative, and you might have gone positive or negative, so you have to take the absolute value of what you answer, so that you don't get a negative value. Then moving on to some examples, we have find the distance between A and B, where A is 3, 5 and B is 5, 1. So you just use the the Pythagoras Theorem-ish. The absolute value of A and B is root y2 minus y1, it could be any way around, plus x2 minus x1. So it will be 5 minus 1 is 4, 4 squared is 16, and 3 minus 5 is minus 2 squared is 4. So it will be it will be 16 plus 4 on the inside, which is 20. And you can simplify this to get root 4 times root 5, or 2 third 5 unit. Well, let's write it in a new color so that you can see it clearer. So it will be 2 third 5 unit. And number 2, find the midpoint of 5, 3 and 10, 4. So as I said, the midpoint, basically you just add x1 and x2 together, 5 minus 10, and y2 and y1 together, and you just simplify it. 5 plus 10 is 15, and it'll be 15. Oh, let's just rewrite this. 15 over 2, and 3 plus 4 is 7, 7 over 2, and that's the midpoint. Then we have calculated the gradient of 5, 3 and 10, 4. So the gradient would be y2 minus y1 over x2 minus x1. So let's just set this as 2 and 1. So it will be 4 minus 3 over 10 minus 5. 4 over 3 is 1, and 10 minus 5 is 5. So that's the most basic, you can't simplify it further, so it will just be 1 over 5 as the gradient. And find the negative reciprocal of 14. It's quite straightforward. 14 is basically 14 over 1, and you have to reciprocate it to get 1 over 14, and you have to add on a negative, and therefore the negative reciprocal of 14 is minus 1 over 14. And lastly, here's a last question, because this question right here is repeated, just ignore this. Find the perpendicular bisector of AB. So we have A and B. Remember, the first thing to do is that you have to find a gradient and negative reciprocate it. The gradient will be 7 minus 1 over 3 minus 6. Oops. 7 minus 1 is 6, and minus 6 plus 3 is minus 3, which is minus 2. You negative reciprocate it to get 1 over 2. That's number 1. And number 2, find the midpoint between A and B. So midpoint, 6 plus 3 over 2, and 7 plus 1 over 2. This will get us 6 plus 3 is 9, 9 over 2, and 9 over 2. And 7 plus 1 is 8, 8 divided by 2 is 4. And 9 over 2 and 4. and that's the basic things that you need. So to find the equation of the new perpendicular bisector, you just combine these two gradient and midpoint as coordinate to find the new equation. So y equals mx plus c, where m, basically this means where like the condition, where the gradient is 1 over 2, and x is 9 over 2 and y is 4. So it will be 4 equals 1 over 2 times 9 over 2 plus c. This will mean 4 equals 9 over 4 plus c. And let's just, let me see, rub the top out. And let's just rub this out. So 4 equals 9 over 4 plus c. So c is 4 minus 9 over 4. And 4 is basically in the denominator of 4, it will be 16 over 4. 16 minus 9 is 7, so it will be 7 over 4. So that's the c value, or like the y-intercept of the equation. Therefore, combining all elements together, the perpendicular bisector of AB would be y equals 1 over 2x plus 7 over 4. Oops, let's just write in the new color. y equals half 1 over 2x plus 7 over 4. And that's our final answer. And that's it for this rules and examples video for coordinate geometry, where today we look into examples and some rules and some formulas like the Shoelace Method. And I hope you'll find it useful and helpful, and if you did, please leave a like and subscribe and ring the notification bell so that you don't miss out on any future videos. And if you have any comments or constructive feedbacks about my channel or my videos or my YouTube or like my website, just drop them in the comment section and I'll reply to them. And if you have any confusion about this topic or any other topics, just leave them in the comment section or email me and I'll reply to you. And check out my social medias in the description, for example Instagram or YouTube or LinkedIn or website. And check out my website for all the resources and lesson slides and teaching resources. Or you can type it out in your browser at www.makesiteasy.com. And I hope you'll find it useful and helpful, and I'll see you all in the next video, which will be the questions only for coordinate geometry. Until then, stay safe and happy learning.